Welcome to Study Loop.
Okay, so we want to show that if f of x is increasing, then this is only if and only if g as a function of x, which is defined as 1 over f as a function of x, is strictly decreasing. So now we'll go in this direction. So we assume f as a function of x is increasing. So what does it mean to be increasing? Well, it means that if x is less than y, then f as a function of x is less than f as a function of y. Now, taking reciprocals of both sides, this implies that 1 over f as a function of x, because you're taking reciprocals, you have to flip the sign. So this is 1 over f as a function of y. So now if you define as g of x as defined above, this implies that g of x is greater than g of y when x is less than y. So therefore, you have g of x is decreasing. Now you have to prove the opposite way, so we have to go this way. So if g of x is equal to 1 over f of x is decreasing, well then once again, when x is greater than y, then g as a function of x must be less than g as a function of y. So substituting as 1 over f of x less than 1 over f as a function of y. So taking reciprocals, once again, you have to flip the signs, f over y. So therefore, f of x is increasing. So since you've proved both sides of the implication that if f of x is increasing, then this implies that g of x is decreasing. So this was proved on the first page. Now you've also proved the backwards one. So you proved that when g of x is decreasing, so when this is decreasing, then f of x is increasing. So therefore you have f of x is increasing if and only if g of x is decreasing.